Greetings. Today we'll look at some examples of literal equations. Solving literal equations, actually. So first of all, we are going to use solve these literal equations the same way that we solve equations. We're going to use order of operations, but using order of operations in reverse. So we're going in the opposite direction. And order of operations, if you remember, is parentheses, exponents, multiply and divide, and addition and subtraction, with addition and subtraction going in order from left to right, and multiplication and division going in order from left to right, and addition and subtraction going in order from left to right. So let's get started. We have the first one, d is equal to rt, and we want to solve for r. So d is equal to rt. So if I want to get r by itself according to order of operations, I'm not adding or subtracting anything to my r, but I am multiplying by this t. So the opposite of multiplying by t would be to divide by t. And whatever I do to one side, I have to also do to the other. So my t's cross out over here, and I get d divided by t is equal to r. All right, the next one, it says solve p equals 144 lowercase p divided by y, and I want to solve for lowercase p. So I have p is equal to 144 lowercase p divided by y. So if you recall, in a previous video, I told you that whenever you have this division bar like this, that there is invisible parentheses up here. So parentheses is all the way at the very end of my order of operations. And I don't have any addition subtraction, but I do have multiplication and division. So I am dividing by this y, and the opposite of dividing by y would be to multiply by y. Whatever I do to one side, I do to the other. So my y's cross out. I'm not going to write yp because in algebra we don't normally write it not in alphabetical order, so I'm going to keep it in alphabetical order. So I'm going to get py. Doesn't matter, it doesn't, but when you see an answer choice, it's going to be py instead. Equals 144 lowercase p. Again, I'm solving for p. I am not adding or subtracting anything, but I am multiplying. So the opposite of multiplication is division. Whatever I do to one side, I do to the other. So my 144 crosses out, and I get lowercase p is equal to capital P y divided by 144. All right, the next one is k equals 1/2 mv squared, and I want to solve for m. All right, of course, according to order of operations. I don't have any addition and subtraction, but I do have multiplication and division. So I am multiplying by this v squared, and I am also multiplying by this 1/2. So I'm going to go ahead and divide both of those. Whatever I do to one side, I have to do to the other. And so I get k divided by 1/2 v squared equals m. Now I can't leave that fraction in my denominator like that. And if you recall, when I'm dealing with fractions and multiplication, I have this 1/2. So I have k over v squared. I can leave that v squared there, but this 1/2, I'm going to take it and multiply it by 2 over 1 because I am keeping the top, changing this division to multiplication, and I am changing and flipping this around. So it's becoming from 1/2 to 2 over 1, and that's still equal to m. I get 2k over v squared equals m. All right, the next one we have a equals a plus b plus c plus d over 4. All right, so remember, you would say, hey, I am adding and subtracting. However, remember, this is an invisible parentheses over here, right? So instead, I'm going to multiply by 4 first. So my 4's cross out, and I get 4a equals a plus b plus c plus d. I'm going to do all of mine in one step. I know the next thing is I have some addition. So the opposite of that would be to subtract d, subtract b, and subtract a. And so whatever I do to one side, I have to do to the other. So that's going to be subtract a, subtract b, and I'm running out of space, I apologize, and subtract d. So they cross out on this side, and I get c is equal to 4 capital A minus a minus b minus d. All right, the next one, it says solve for w. I have s equals 2l plus lh plus 2 times lw plus lh plus wh. So gonna write it down first. First thing I'm going to do, according to order of operations, this is in parentheses, so it's at the very end. I have a multiply by 2. I'm going to divide both sides by 2. So it crosses out here, and I get s over 2 equals lw plus lh plus wh. All right, I'm solving for w. So these two are multiplied. So I'm going to go ahead and just subtract my LH from both sides. And I get S over 2 minus LH equals LW plus WH. Now I have a bit of a conundrum because I have W's for my LH plus my a W for my WH. However, I can't subtract those. I can't divide those according to the order of operations. So instead, I need to do something a little bit more tricky in my thinking, trying to manipulate these variables in some type of way. So I am going to, actually, I need to make myself some space. I hope this is okay. I'm going to delete this. If you need to go back and copy it, feel free to do so. I have S over 2 minus LH is equal to LW plus WH. I see both of these have the same factor. I'm going to factor it out. So I'm going to pull out a W. So I have L plus H now, right? So if I pull out a W, I have L is left here and H is left here. Now, I'm multiplying by L plus H, right? So that means I can divide both sides by L plus H. I'm going to have to get rid of this so it's not confusing. All right, so my L plus H crosses out, and I'm left with S over 2 minus LH, all divided by L plus H, is equal to W. Now you might say, hey, Dr. Case, you don't want to leave that fraction up there, do you? I don't. Normally I wouldn't. And you know what? I'm not. So let's go ahead and get rid of that fraction. Let's talk about how we get rid of it. So I'm going to have to do some deleting. I hope that's okay. All right, so I have an invisible over 1 here, right? And I need it to be 2. So I'm going to multiply this top by 2 and this bottom by 2. So I get S over 2 minus 2LH over 2, everything over L plus H. So then everything is still equal to W. I'm going to put it equal to W over here so we don't forget that. I can now put this all S minus 2LH over 2, everything over L plus H. So now I still have two fractions, right? Don't want to leave it like that. So again, we're going to keep the top term. So that's S minus 2LH over 2. Change this division to a multiplication. And change this, because this is an invisible over 1. I'm going to flip it. So it's going to be 1 over L plus H. And so when I rewrite this, I get S minus 2LH over 2 times L plus H equals W. And if you like, you can change, this is also equivalent, right? I can also say S minus 2LH. If you want to go ahead and multiply that 2 through, this is quite all right. All right, last one. We have y minus y1 equals m times x minus x1, and I want to solve for x. So I have y minus y1 equals m times x minus x1. All right, according to order of operations, this is the side I'm looking at because I want to get this x by itself. This m is the first thing that's in my way. I'm multiplying by m, so the opposite will be to divide by m. So I get y minus y1 divided by m equals x minus x1. All right, so now the thing that's in my way of getting my x by itself is this x1. So I'm going to add x1 to both sides. And I get x1 plus y minus y1 all over m equals x. And I hope that this helps.